This is no mailbag. I'm not that big of a YouTuber. Every couple of weeks, I tend to go to the flea market that takes place in Bucharest, basically every Thursday, Saturday, and Sunday. And I usually go there and come back with a whole load of interesting and weird things, especially old Soviet surplus, mixed components, and stuff like that. And this day has been particularly fruitful in my searches, and I decided to film a bit of what I found in the flea market and share it with you guys. So let's take a look. First up is a Automis AD17 Alpha Beta Gamma probe. Automis is a German manufacturer of Geiger counters, dosimeters, and other radiation detection equipment. This is an end window probe, so you can see there's the mica window behind that mesh. It has this weird and very expensive Fisher connector. It's a 6-pin. These are held to connect to a cable because they have very tight requirements in how we have to strip the wires and how you have to solder them, and assembling the plug is very difficult. I used to do a lot of these when I worked for a research institute when I was a bit younger. So let's take it apart and see what's inside. I'm suspecting this is a built-in high voltage generator probe, so it doesn't require an external high voltage supply from the base unit. And after we take out some screws, I'm expecting also a weatherproof seal of some description. So let's take out a connector. You can see it's a 6-pin plug, very nicely made, very expensive. Actually, extremely expensive. These are rated for thousands of mating cycles, and they're very, very nice. So we can see a PCB with a couple of switches and the Geiger tube itself in the end. And the thing caked in a bit of white grease is an O-ring, so the whole thing is basically waterproof. If we take out these two screws, we can extract the PCB and see that there is indeed a high voltage supply on the board. There's a lot of circuitry on it for such a simple device. So what we have is a reddish filter capacitor in the top left, and then we have some logic ICs and a section dedicated to generating the high voltage. So this is probably an inverter configured as an oscillator driving that transistor, which drives that transformer we saw on the other side, rectified output, and filter it into those capacitors, which then goes to the anode of the tube. It comes back and the pulses are discriminated by those circuits, and they're, I think, applied to the connector as a TTL output. That's a very interesting 2 gigohm resistor probably for the feedback of the high voltage. So you can see it's a very nice circuit, very clean, and yeah, it's probably quite expensive to buy such a probe from Automis as a new item. Oh, also that capacitor is a tantalum capacitor, and I recognize them because of the stub marking the positive side. Next up, we have a couple, actually 3, Soviet SBM-20 radiation detectors, Geiger-Miller tubes. These are very, very common and widespread. They're extremely expensive at the moment, around 20 euros. And the reason I bought them was because the guy was only asking 5 euros a piece. And I have a Pripyat counter, actually a dosimeter, and it has 2 of these inside. So I bought them as spares for this, in case the tubes inside ever go bad. Next up is this thing. I have no idea what this thing is. And it was connected to this thing, which I'm pretty sure I know what it is. So this is an HP Yig-tuned oscillator. And wait a second. That's better. This is a Yig-tuned oscillator coming from God knows what piece of equipment stolen from wherever, but it wasn't connected like this. So this was connected to that thing which I don't know, and the output of that thing which I don't recognize was connected to the front panel of the instrument. So let's take a look at this thing first. So you can see that it's a 3.2 to 6.5 gigahertz Sieg oscillator. It has several coils inside, each with a specified resistance. These are magnetically tuned, so the frequency of the output is dependent on the intensity of a magnetic field which surrounds a Yig crystal, and that's about the extent of my knowledge of these things. I have no idea how they work. I just know it's about ferrimagnetism and a single crystal of yttrium iron garnet. So we can see there's a few resistors and capacitors and ferrite beads inside, and the whole thing is shrouded in mu metal, I think, or ultrapermalloy for magnetic shielding, because these are magnetic devices and they're susceptible even to the magnetic field of the Earth. So massive steel construction, very heavy, and this looks like it's been laser welded. I'm not entirely sure. That looks like a weld bead to me, but feel free to comment if I'm wrong. It might be that behind these behind this PCB itself, there might be some screws which hold the device together, but I'm not sure. And I first want to test it on my spectrum analyzer and see if it works, because if it works, it might be useful for some other project. So gold-plated in typical HP fashion from the 70s, 80s, and it seems very nice. So what I'm going to do is just put it back, hopefully not break it, and figure out the pinout for it, and I'll come back to you when I have it on the spectrum analyzer and we can see what is going on. This thing, on the other hand, I have no idea what it is. It has an input and an output. The input was connected to the Yig oscillator, and it has several power pins. My suspicion is that it is a sort of an amplifier. You can see there was some thermal paste I got all over my fingers, which is coupling it thermally to the rest of the enclosure. It says Hewlett-Packard, made in the USA, C-band, and a part number, but I have not been able to find anything about it whatsoever. So my suspicion is that it might be some sort of amplifier or programmable gain amplifier meant to level the output of the Yig-tuned oscillator, because their amplitude is not really constant over their entire frequency band. So my suspicion is that this being connected to the Yig output amplitude not being constant was regulated by the gain imposed by this device. So maybe I'm wrong, maybe I'm right, maybe I have no idea what I'm talking about. Feel free to comment if you know any better. I am not an RF engineer. Yeah. Anyway, it says fragile on it, so I'm gonna keep them as intact as I can and figure out what to do with them when I know a bit more. But excellent find for about $5. This is pretty high on my sketchy list. So a battery, AliExpress special induction heater, non-rectified flyback, multiplier out of an X-ray head unit, because of course, and feeding into a Soviet image intensifier. So my power supply is dead, my Siglant is completely dead and it's being serviced, so the only power supply I had was that battery or my SMU. And you can see that after shorting the battery to the induction heater for a bit, I can get enough high voltage to charge up the multiplier and get some phosphorus lighting up on the intensifier. And if I put my finger behind it, you can see the shadow it casts on the phosphor screen. So this thing is probably fully functional. It's probably out of an old Soviet night vision scope. That's the extent I know. So pretty sketchy setup right there. Next up, So I was telling you about my Roden-Schwarz spectrum analyzer. Well, not a Roden-Schwarz, not necessarily about that Roden-Schwarz spectrum analyzer. I was trying to fix another one a few days ago, but it was completely dead, and digital section of it is entirely dead. There's no booting, there's no signal output from anything. So that's the thing I was interested in, a Pentium MMX. So the single board computer inside the spectrum analyzer has one of those Pentium MMX chips inside, which I was suspecting to be dead. And I wanted to fix it by buying a replacement, and luck has it that I actually found the complete Pentium MMX single board PC at the Fleamarket, but sadly it wasn't a problem. So RAM, CPU, exactly the same as in the Roden-Schwarz one, but apparently something else is broken in the digital section. This is a very nice board. It's actually 12 layers. Those are some flash chips, I suspect. The LTC parts are the buck converter controllers. And yeah, this was a very nice industrial single board computer, probably made in the 90s or something like that. So yeah, that Pentium MMX was what I was looking for, and surprisingly I did find one, but first of all, this is a 1.9 volt, I think, core voltage device, and the one in the Roden-Schwarz was actually 2 point something, I can't remember exactly. I tested that CPU on a different board and it's fine, so it boots. I didn't risk putting this one into the spectrum analyzer because I'm assuming I can't set the core voltage for the chip, and I would just have a dead Pentium MMX on my hands. So yeah, I'm not entirely sure. I don't know much about vintage computers, but I suspect that I will just have to find a complete replacement for the digital section in that spectrum analyzer. And the only reason I want to repair it is because the one I currently have only goes to 7 gigahertz. That one is a 26.5 gigahertz model. And it also has a tracking generator, which mine doesn't. I'll probably do a video about it at some point. Another small find, a couple of octal sockets for vacuum tubes like EL34, 6L6, 6V6, etc. And only three I could find 9-pin sockets for preamp tubes, 12AX7s and stuff like that. Next up, also a bit smaller, I bought this lens in order to test the image intensifier out better at night when I'm not saturating the hell out of it. It's pretty dirty inside. I don't know how much you can see inside it, but yeah, it should work for a quick test. Another quick find was this thing, which I'm pretty sure you know what it is. This is an ATM keypad, and it's one of the most robust keypads you can ever get your hands on, but it's completely and entirely useless because of what's underneath that thing there. Like the kill EPP sign there. I'm not entirely sure what EPP means, but it's a tamper-proof device. So give me a second to take it apart, and we'll talk about it in a bit more detail. The keys feel very mushy, by the way. I think you all know how these feel. Made by Verifone, and it actually has a USB socket in there which connects to the rest of the ATM. So using the screwdrivers my GPU came with, yeah, you can see that giant block of potting there, right? Yeah, that's very important. So there's a backup battery and a USB connector, 3 transistors and some capacitors, and that's it. That's everything an external malicious attacker would be able to access. There's even a switch which detects tamper. So if you remove that cover, that switch deactivates, and I'm assuming that something inside completely destroys itself in order to protect what's underneath that black epoxy, brown epoxy coating. So you can see the membranes, which are carbon conductive silicone thingies. Some of them only contact on the periphery, on the outer edge, and the others contact the middle as well. I was just very intrigued about that construction. It's maybe for detecting just the type of key, or I don't know why. But look at this PCB. You can not see any traces, and the keys which are for the pin, where you put your pin in, are these ones on the right side. So all the traces from the keys go straight into the middle of the board, and they get scrambled everywhere. And then they get into this block, which is probably just the interface, and its sole purpose is to scramble the key presses so you can't sniff any pin, whatever you try to do. And I'm assuming it's that thick in order to resist any attempt of reverse engineering. This is the level of paranoid design which you need to do when you have basically the finances of everybody at your fingertips. And a close friend, will try and X-ray this thing, but I'm actually suspecting that epoxy to be filled with lead. Last but not least, a funny story about this hard drive. I didn't need a hard drive especially, but I have a K6 system which I want to play vintage video games on. So I found this Hitachi 250 gig IDE drive. It's a 7200 RPM one. It's very nice. It actually works. And I managed to not only boot off of it, and it showed up as a Siemens DVR, but I also could connect it to another computer which has an IDE port, and I actually found some photos of an arsonist at the university campus here. So I cannot show those for obvious reasons, but this was the security systems for the campus. And whoever wiped it didn't do a thorough enough job, because there were still some photos left on this thing. So yeah. So this was decommissioned around 2011, and it's now made it into a flea market. Imagine that. Okay, so I'm sorry I don't have any outros, but I'm gonna leave you with this nice photo of the phosphorus from the image intensifier, and I'll be back with it actually working with the Geiger oscillator on the spectrum analyzer, and hopefully a lot more. Thank you for watching.